Thank you. Good morning. I'll be doing a little bit of talking about some work we're doing for Air Force's Project Jericho. Project 16 is to improve our education and training. It represents only about 3 or 4 weeks of work so far, but we're very pleased by how it appears to be going. I'll try and give you here a quick idea of our strategic problems and why we picked on simulation to solve our big problem. I'll be using lots of examples from our officer aviation training system, which is reasonably complex, a small number of students, but a large amount of cost involved in it. And but just as an example of some of our problems, I'll talk a little bit about simulation in the Air Force. We haven't got a long experience with it. I'll be giving some results about a simulation prototype that we built, which at least verifies what we think is happening, and we've started building a more mature model which will be used for validation against the current training plan. The focus question is, what can we do to improve our training scheduling? What motivated this was Air Force Training Group had a bit of a look at their current output, and it's decided that we're wasting about $4 million a year in direct costs by making students wait in between courses. We call it waiting time, pooling time, white time is what aircrew call it, but about $4 million a year in direct costs, which is accommodation, travel, salaries. Doesn't include indirect costs like the loss of capability for graduates that should be out at the squadron somewhere, and it doesn't include the cost of demotivating students while we sit them around in a school painting rocks white. Air Force Training Group currently trains about 8,000 students a year. We've got 327 different courses. Some students do more than one course a year. Some courses are run more than once a year. It's like a small university. The current problem is scheduling challenges. If you leave it up to the schools, they're usually motivated to run a small number of sessions each year on a course with a large number of students. It greatly simplifies their local scheduling issues. The problem with that is that by construction tends to lead to waiting time for students in between 2 consecutive courses. And we don't have any good idea of where the problem is, how bad it is, what we can do about it. That's where I'm up to at the moment. So lots of inefficient pooling. We've got no real way of measuring our current training program. Largely, the training program that we have today is based on the one that we had 50 years ago, and it's changed very slowly over time as we've introduced and killed off courses. We do have some integration with workforce planning, and really that's recruiting targets, pardon me, imposed on defence recruiting by Air Force headquarters. Defence recruiting has got some contractual incentives to give us students to train, and then we try and train the right number to meet our targets. Military training, there's still, most of it is training level, competency based. You either pass or you don't pass. We aspire to meet our training targets every year, but we don't change our pass mark to do that. The officer aviation stream, the writing is small, and I'm really only trying to convey that it's complicated. Officer aviation are our pilots, our air combat officers, they sit in the back seat of aeroplanes, and our air traffic controllers. There are 8 different courses explained here. The little yellow balloons are every place where there's an opportunity for a delay. It's possible, under the worst possible circumstances, for a student to spend 6 years in training, which includes 3 years at ADFA, and some of that might accumulate to more than 12 months of delay between trainings. So, looking at the stream across the top, students come in from DFR, they then go to an initial course, which is military skills at ADFA or Officer Training School. Across the top, they do an Air Combat Officer basic course. They'll be then streamed into one of the 3 Air Combat Officer streams, which is fast jet, Wizzo, sitting in the back seat of a Hornet, or maritime, sitting in the back of an Orion, or ABM, which is where they watch dots on a big screen, either in the back of an EWAX bird or even on the ground somewhere. In between all that proper professional training, there's AVMED courses, another opportunity for delay, and combat survival courses. So those three outputs represent something like 5 different courses so far. The pilots have a similar sort of a system with combat survival and AVMED, but there's more kinds of graduates. We tend to treat fast jet pilots one way, multi-engine, multi-crew pilots a different way, and the third stream that we're starting to get is UAV pilots. We haven't actually trained any UAV pilots from scratch yet. They're all currently fully trained and qualified pilots. Finally, across the bottom, the third part of the Happy Officer Aviation family is our air traffic controllers. They do much of the same training. They have to have many of the same skills, particularly situational awareness, and most of their training happens at the same place, at East Sale. Their initial course is a bit different to what civilians do. They get a course that qualifies them to operate surface movement in a control tower or a control tower. After a year or two in the field, they'll go back into training and do another fairly long course to qualify for radar area control. There's a lot of articulation between those streams. Air Force is great at recruiting pilots. We're less great at recruiting ACOs and air traffic controllers, and there's a lot of articulation. If you fail pilot's course, then you might get offered a chance to do air combat officer or air traffic control. There is some articulation in the other direction, but only some. Every one of those yellow balloons represents an opportunity for delay. The AVMED course is a great example. It's really only 2 days of training at Adelaide, but it takes our students out of the rest of their training pipeline for about a week and a half as a rule, with travel and waiting and things like that. My background's really in mathematical modelling and optimisation. This one here, if you tried to treat it as an exact mathematical modelling approach, the computational complexity would kill you very, very quickly. It is multi-objective. Most of our focus so far has been on controlling cooling time, but it's multi-objective. We don't want to reduce cooling time down to a minimum at the expense of upsetting all of our instructors, for example. So there's a multi-objective issue there. The multi-objective issue there tends to confound your interpretation of output variables and interpretation of things like shadow prices. That's one of the problems. Most of what we're doing here is stochastic. Obviously, pass rates are stochastic. Number of candidates is stochastic. There's lots of things going on. And business rules, these sorts of problems, business rules can be either soft rules or hard rules. Hard rules are ones that you treat like constraints and would satisfy every time. Soft rules are ones that you aspire to satisfy, but you'll occasionally relax that constraint and perhaps run a panel of students with 1 or 2 more than you hoped in it. Mostly 1 or 2 students in a typical course doesn't hurt much. The approach that we've taken is to treat all of our constraints as hard constraints, see if we can satisfy them all. Air Force has a long and proud history of simulation. We've got lots of cockpit trainers, task trainers, marshalling simulators, maintenance simulators. However, we've had very little experience with mathematical simulation. And I'll categorise those examples as discrete event simulators as opposed to discrete time simulation. In fact, I believe I met Mark, who's the first master's graduate coming back from US Air Force Institute of Technology, returned in the last 12 months with a master's in OR. I believe it's the first time ever that the Air Force has tried to train someone in OR and these sorts of technologies. We're just engaging with it very, very recently. The prototype that we've built, we were hoping to get it to the point where we could verify what was happening. We wanted to get start doing the knowledge engineering and capturing the distributions and parameters. I think we've got there. I'm pretty happy so far. We'll certainly be able to report some results for you. The series of little blobs in the top right-hand corner is really just to prove that we've given some thought to a concept diagram, bubble diagram. Across the top, there's parameters, distributions for most of the inputs, courses, instructors, resources, precedence rules. Down the middle of the bottom there's a blob, which is the model, And coming out of the model, there's a basket of output variables, which includes pooling time. That's how we built the model. That concept diagram is being modified every day as we keep playing with it. The prototype that we came up with was to come up with 3 courses, dummy courses. Each course was different. Everything that could be stochastic, we made stochastic and used lots of different examples of uniform distributions, gamma distributions. So we tried to provide an example of everything that could happen, given it was only a little prototype with 3 courses. So down the bottom there, you can see a approximately normal distribution, a triangular or beta distribution, and a uniform distribution. As a real rule of thumb, Air Force training pass rate is about 80%. However, that doesn't mean 80% of students end up where they want to be, because there's generally more than one course required to get you into a professional job. The prototype, really good. We've now started capturing business rules. We've started unscaring some of the public service professionals who are running the training program at the moment. We've collected parameters for a lot of things and distributions. We've got a basket of objectives that we've started looking at to find out whether a really good pooling time solution might give us a solution that's unacceptable in some other way. But there was no understanding of what might happen there until we started getting results. We've now got pseudocode. One of the unusual aspects of building this model was that we tried to build 10,000 replications of feasible solutions. That means satisfying all constraints, satisfying everything possible, and then assess each one for pooling time and the other basket of objective variables, and then have a look at it. And we're getting some pretty good results. The one at the top there is basically pooling time. This particular small prototype says that pooling time is as good as about 25 days for a student, or as bad as about 62 days for a student, and the average is pretty close to about 45 days for a student. It's not hard to choose a solution that is right down the bottom of that distribution. So we're confident we can get somewhere with this. Lots of objective variables over there on the left. The little chart in the bottom right-hand corner is talking about our targeting success, where ideally we would have 0 graduates. That means not too few, not too many. That sort of vaguely normal distribution is exactly what I would expect with all the stochastic variables, and one of the things that gives me confidence that we are verifying the model successfully. Where we're up to. This represents only about 3 weeks of work by an old reservie so far. We've just got AnyLogic installed after Air Force Headquarters killed the laptop that was doing the work up until that point. AnyLogic is what's being used by DSTG, Algora team, to do some related work here, which has a slightly more workforce planning focus. And so some of the parameterization work we're doing is useful to them, and vice versa. AnyLogic model is what we'll be developing for the rest of this year. It'll be a discrete event simulation model, but we'll be treating students and instructors as intelligent agents. The ability to get sick, the ability to pass or fail or not turn up. Air Force Training Group currently has 3 wings. Initially, we'll concentrate on Air Training Wing down at East Sale mainly, because that's the expensive part of our training. Small number of students, highly expensive aviation training. Ground Training Wing is the cheapest and the largest number of students. That's basically initial military training for a troop, and RAF College is postgraduate and technical training for other people, troops and officers. We intend to do it in that order. ATW is small and good bang for the buck. GTW is simple but large, and RAF College will come after that. That's the reason for it. Once we get it going, I reckon we can validate the AnyLogic model against our current annual training plan. And it will be the first time we've had a chance to do some scenario testing, investigate some output variables, and put a bit of science into what changes we might want to make to the training plan. And most of that work should happen after Christmas this year. Maintenance is something that's going to be a real mess. Air Force has very little organic ability to do this sort of work. So we're anticipating problems with maintenance. That's something we'll wrestle with once we know we've got a model that's working. Thank you.
Thank you for the presentation. My question's about the use of historical data so far. Do you have in mind to use the historical data to try and test the versions of the model that you end up with for validation?
We've looked at that and we found the last 3 to 5 years, like in most finance modelling, last 3 to 5 years data seems to be most informative because there's a lot of paradigm shift and change in our training. Last 3 to 5 years tells us more about what will happen next year.
Well, one of your graphs said, I think it's average 8% pass rate, so that's a 20% wastage rate. Probably not necessarily your lane. Is that something the Air Force is looking at to try and reduce that further and save more money for reducing those sunk costs?
Very complicated question above my pay grade. The answer, well, for an example of what we're doing there is we're introducing the Aviation Academy at East Sale. The Aviation Academy has historically trained pilots, air traffic controllers and air combat officers. We give Defence Recruiting a target number of students that we want. If they get 20 people walking through the front door on the first day that satisfies the target, they send them down to us for training. And the 21st person that walks through the door the next day will never get a shot at that course, even if he's extremely promising, because of recruiting contract complications. We're going to change that. We think that we can select students better than DFR that will be promising at officer aviation. So we're going to start letting them screen out the obvious psychos and obvious unsuitable people, and we'll bring them down into a no jeopardy training system of about 2 or 3 months where they'll get exposed to officer aviation tasks. They'll get some training which will be useful to them, but no jeopardy. They can't fail at that point. However, we'll assess them for competitiveness and suitability for the next level of training. If it works, we'll probably transfer that scheme onto M and aviation. That's load masters and other people in the back of aeroplanes. And if it works, we'll continue. But I think most Air Force would agree we're lousy at writing contracts, and we haven't written a contract with DFR that is effective at selecting students for training.
Any more questions? So I think, oh yes.
I know there's been previous years, last 10, 15 years, when there's been identified high wait time for students overseas and navigators across the Canada, for example, that kind of thing. Given there's a big $4 million potential waste every year, in the short term, is we looked at to outsource or overhead this to other countries to meet the need?
Has been in particular for the Growler, that's the F-18G, the new ones that they've got in the Amberley. US Navy and US Navy can train Growler backseaters really, really well, so we're looking at that. But we also have to maintain the School of Air Warfare, now named 1FTS at Sale, which does all ACO-related training. And I think 1FTS at Sale would rather continue all training if they can be resourced and trained to do it. As a stopgap, we may end up sending some guys over to US Navy. But that tends to be a stopgap, not a long-term